In this video, we're going to create a simple slime enemy, start building a slightly more flexible state machine for our enemies, and create the idle and wandering states that we'll use to start building our slime. Hi, my name is Michael, and welcome to my 2D action and adventure RPG tutorial series. We are learning how to build a top-down 2D game that features action, adventure, and RPG mechanics all in Godot 4 using GD script. Okay, so let's start by setting up our folder structure and getting everything ready for the enemy assets that we're going to be working with. We'll start by, in our resources, let's just create a new folder here. We'll call it enemies. If I can remember how to spell that. Okay, so we'll put all of our enemy related things in here. Let's add another folder underneath it for our scripts. And let's see, we're going to have one enemy that we'll create. We'll create a folder for this enemy. I'm going to create a slime enemy. Okay. And then we're going to want to open our slime enemy folder in the file manager. And then grab our tutorial asset that you can download from my itch.io page. Just plop that in there. And now we've got our slime sprite sheet in here. So everything should be set up to get going. Okay, now that we've got our folder structure set up here and everything ready, let's go ahead and actually create a new scene for our slime enemy. And I'm doing that in the slime folder here. Call it slime. Okay, there we go. The slime actually shouldn't be a node 2D though, so let's click on this and let's change the type to be a character body 2D, because we're going to be moving this via script. We've got a warning that we need a collision shape. We'll add that in just a moment. First, I want to add our sprite 2D. This is going to represent our slime, and let's go ahead and take this slime PNG that we downloaded and added to our project. Drop it on the texture. There we go. And under the animation section, let's set the horizontal frames to 16 and the vertical to 2, because that's this sprite has 16 columns and 2 rows. Okay. I'm going to go ahead and just drag this up slightly so that the bottom of the slime kind of fits in the middle of that origin. And I want to add another child node, another sprite 2D for the shadow. Go ahead and rename this. I don't know. Shadow sprite 2D. And then we'll just use the same shadow sprite we use for our player here, because it happens to fit pretty good. And I'm just going to go to visibility and modulate this. And instead of black, I want to use actually like an orange color, so that he has like a shadow that would be colored as if he were translucent, because he kind of is, I think. He's a slime after all. And then we just need to drag this below the sprite 2D. And I don't know, maybe reposition it. Just make sure it looks good to you. And then now that we've got these in here, let's go ahead and add our collision shape to this player body, because it needs it to know. And actually, yeah, let's keep this down here for a second. For the shape on this collision shape, I want to use a capsule, because I think it fits the slime a little bit better. And in fact, this might even be worth doing to the player at some point. But I'm going to rotate the capsule by 90 degrees so that it's horizontal like this. And then you can just adjust a capsule by clicking on these nodes. You know, if you had the select or the move tool, then you can just click and drag a little red dot there and resize this as needed. And I'm going to do something like that. So I've set the radius to 5 and the height to 20. So if you don't want to use these, you could always select it and just set those manually. There we go. We've got our collision shape so that the slime can bump into stuff. This collision shape is going to detect collisions with things like walls, just like our player. And we're not going to use it to detect collision with the player itself right now. Let's go ahead and select our slime, I guess. And why can't I find it? Under collision, I think what we want to do is turn the player and the mask off, or not the player, but the player layer on the layer and the mask off. And then we're going to put him on layer 9. Not sure what happened there. Okay. I think I had something in memory, because I actually deleted this and restarted it. I made a mistake. I wanted to restart this recording. So ignore that message. You shouldn't get that error message. But I want him to be on the enemy layer. And I want the mask just to be looking at the walls layer for this. And I think that's all we need to do. In fact, we may not even need him on the enemy layer, but for now that should be fine. Okay, so go ahead and make sure that your collisions are configured that way. And then real quick, oh yeah, I do have my other slime open. Let me close that. So ignore that other slime tab. So let's go to our playground and let's just, I had 2 slime scenes. I'm going to delete the one with the capital S. That was my old one. Let's go back to slime, save it again. Okay, now that I fixed that, we have 1 slime scene. You should have only had 1 to begin with. Let's just drag this guy out. Oh, there we go. Nice orange slime in the middle of the grass there. And let's save that. Okay, so we're ready to kind of start setting up our slime a little bit. Now I want to go ahead and quickly set up the animations, and I mean quickly is relative. I'm going to try and get through this as quick as possible because we've done animations before. So I'll set this up and maybe give some explanation to some things that I'm doing differently to previous animations we've done. And you can just kind of pause the video and add things as needed. Before we can do that, of course, we need an animation player. So let me add that to my scene. And then let's just go ahead and make sure you have the animation player selected and create a new animation. And we'll make an idle down. Let's start there. Now this idle down animation, I've already built this before, so I know it's going to be 0.4 seconds in duration. And then let's just select our sprite and key the frame. Go ahead and create that. And then let's also actually key the position. Okay. And I actually wanted that key at the beginning. So if your play head was somewhere else, it'll create the keyframe elsewhere maybe, but I want that on the first frame. And we're not going to change the position on the idle, but we will on the walk. So this position keyframe is going to be important for all of our animations on the slime. But for the walk, we'll just simply drag our playhead to 0.2 or so, insert a key, and then another one at the end. And then let's see, this frame should be 1 and 2. And this animation will ping pong. So let's just preview that. 0, 1. Oh, yeah, it's not looking good because I didn't make that a 2. Okay. Normally you wouldn't want an animation frame on the very end, but when you're ping ponging, it'll actually play it for a little length of time. But if this were just looping like this, just a regular loop, and then we hit play, then we're not going to really see that last frame. So we would either need to drag this in or extend our animation, you know, by another 0.2 seconds or something. With all that said, I want it on 0.4 and I want it ping ponging. So you should have a little, you know, swaying back and forth animation happening on your slime. And then real quick, let's just go ahead and produce the other idle animations. So I'll fast forward this while we do it. We're going to make the idle up and idle side. So I'll start there. Okay, we've got those completed. And then what we're also going to need today, we're going to create 2 states on our player. We're going to have an idle state, and we're also going to have a walking state. We'll for sure get that far, or maybe not walking, but wander. But we want a walking animation while he's wandering. So I'm going to go ahead and just pick idle down, duplicate this, and we'll call it walk down. Okay, now this animation, let's see. We are going to animate the position, and we're going to have a few more frames. The duration of this animation is going to be 0.7, and the loop type is just going to be regular. We're not going to do the ping pong. So this starts on frame 9, and then at 0.2 seconds, we want frame 10, and then we want frame 11 at about 0.4. So you should have something where he kind of squishes and then extends. And then right before we end, we do want him to go back. Let's insert another keyframe here, and this will go back to frame 9 at the end. You can change this if you want, but I've got an animation that's going to look like this. Obviously that's not super cool just yet, but we'll spice this up with a little bit of animation on the position. So let's say I'm going to just select this keyframe here and then drag my playhead to 0.2 and then right click and say duplicate keys. So we've got another position keyframe. He's going to stay on the ground on this section of the animation. But then let's go somewhere, I think about here, maybe 0.5, and insert another keyframe. And I don't want him to animate a whole lot. He was at -19. Let's just subtract 4 from that, maybe. Boink. So he'll hop up, and then he is coming back down, but just to be safe, I'm gonna actually duplicate that keyframe there, the original one. Now, one thing that we want to do with this position, it actually looks okay, but it's a little bit jarring because it's got a linear interpolation, which means it just steadily progresses from position to position and then back down. We can drag and select all of these keyframes, and this easing value right here, you can adjust this, but I'm just going to right click and select ease in, ease out. And you can see that already kind of smoothed his animation just a little bit. Whoop. It makes it feel a little bit more natural. Okay, so there we go. We've got our walk down animation. And once again, we'll just duplicate this and create the others, so you can pause as needed to input any values, and I'll put those on the screen. But I'm going to go ahead and just do that right now. So there we go. We've got a full set of animations, one for each of the states that we're going to begin with on our enemy here. I suppose one last thing we should do, I don't know that it's going to make a huge difference, but I'm going to select my idle down animation and make sure this is set as autoplay on load. If we test our scene, then he should be idling when we start. Yeah, there we go. Little slime, little idle. So now it's actually time to move on to creating our enemy script. Now this enemy script is going to look a lot like our player script. And in fact, if we were being extra careful and smart about our code, we would probably have one common script that both our enemy and our player inherit from and extend. I'll leave that as an exercise to you if you want to do that though. Hopefully that seems fair, but I'm just going to right click on my scripts and say create new script. And I'm going to just call this one enemy. Okay. Let's open this up. We could copy and paste our player, or we can just create it here. I'm going to opt for just creating it so that I can explain as we go each thing, but I am going to try and go quick over some of it. So the class name is going to be enemy, and it should extend to character body 2D. Okay, go ahead and save that so it updates. Now, one thing that I know we're going to need is we're going to need some signals. We've got the direction changed signal. Much like our player, and this will emit a new direction, which will be a vector 2. Okay, and then we also want a signal called enemy damaged, and I think we'll want to add parameters to this signal later, but for right now we just want the signal to exist. Now we had a constant in our player for the direction types, so I'm just going to copy and paste that in there. Our dir4, we need that here. And then let's add an export variable. We only need one to start, and we're actually not going to use this a whole lot today, but we'll set it up. So we're going to give them an HP value. I'll make it an integer, could be a float, you know, depending on how you want to track those. So that will appear in our inspector. And let's just go ahead and save and drag this onto our slime. So you'll see what I mean. There's the HP. By default, it'll be 3. So obviously you could set that to 1 or 0, or, well, I guess if you set it to 0, he would be dead on spawn. So maybe don't do 0. Now we need a few other things, and let me paste these in here. We need our cardinal direction, just like our player, as well as regular direction. We're also going to store a reference to our player so that the enemy will have that if needed. We will use this minimally, and there might be better ways to do this, but I'm going to plug that in there for now. And then a Boolean to say if they're invulnerable or not. And these items might not come into play too much right now for the walk and wander, or the idle and wander states, but I know we're going to need them in the future. So go ahead and put them in there. And then we just need some on-ready variables, and they'll look like this. We need an animation player reference, a sprite reference, hitbox reference. Let's see, we don't have a hitbox yet, so let me comment that out. And we don't have a state machine yet, so I'll comment that out. And as soon as we add these, we can begin integrating them into our code. We'll go ahead and leave process alone right now. We want to hook into the physics process. So let's go ahead and put that in there. I'm going to put an underscore on delta because we may not use it. But for now, we'll just do like we do in our player, and we'll just call move and slide right here in our physics process. And then similar to our player, we'll be setting a direction and calculating a movement outside of the physics process. Now we had a set direction function in our player, and we need the same function here, and it's going to function identically, I think. So you may be able to copy and paste that, or you can just take mine. But just as a review, this function, we're going to take in a new direction, which actually I think that's different, right? Because what did we do in our player? Let's just reference that real quick. If I look at the player scripts, yeah, our player set direction didn't take a direction in. Instead, we got that based off of here in the process, the direction that the player's pressing. The enemy is different because we're going to be creating a real basic AI to control the enemy, and it's not going to be based off of player input, right? So instead, we'll provide a direction to the set direction, and that's going to happen on the different enemy states. So really, that's the only difference between this and the player version of set direction, right, is how we get that direction. Okay, so we'll set the direction here to the new direction, right? And direction is this variable in our class. We'll set it to the new direction we pass in. If it's 0, we're going to say that there's no direction, kind of just like our player. Figure out the direction in terms of the cardinal directions, up, down, left, and right. If it's the same, if it hasn't changed, just return false. And if it has, then we'll set the cardinal direction, emit the direction change signal, and we'll flip the sprite if we need to. And then it'll return true if it gets all the way through these conditions. We also are going to want an update animation script, just like in our player. Yeah, so we've got our update animation, and of course we've got this anim direction that we require. That's why we get an error here. So let's go ahead and put that in here. And this anim direction, remember, just looks at the cardinal direction and returns the up, down, or side that we need for our animation name. So we'll looking again at this update animation function, we'll pass in a name. It's called state, add an underscore, and provide the direction. And so that's why we've named our animations the way we have here, so that they're easy to get through code. And then I think that'll be good for the basics of this script. But we need to do a little bit more. I think we'll handle that later. We'll come back and we'll update the state machine and things like that once we've created it. Okay, the next thing we need to set up for our enemy scripts is we're going to need to create a state machine, right? Kind of like our player, and it's going to function basically the same way. There might be some small differences. So let's look at our enemy scripts folder, and I'm going to go ahead and create a new folder in here, and we'll just call it states. Inside the states folder, we'll create a new script called EnemyState. And let's go ahead and open this up. We want to build this class before we start building our other classes, because we're going to have errors in our code throughout the other classes if we don't build this one. So let's just give it a class name of EnemyState. And it extends node, that's fine. Now, we're going to need to do just a couple things here. First, we want to store a reference to the enemy and the state that it belongs to, right? And this will just be a static variable, just like our player state. That way we actually don't want this to be a static variable, I don't think. We'll make it just a variable called enemy. And it's of type enemy. And then we also want a state machine reference. And this will be of type EnemyStateMachine. And we don't have this class yet. So let's go ahead and let's just create that. And I'm not going to create that in the states folder. I'm going to create it here at just in the enemy scripts folder. So we'll just call this EnemyStateMachine. Okay. I'm going to open this up, give it a class name. Okay. And then that hopefully, once we save this, that'll help clear this error in a minute. Let's go ahead and work on this EnemyState class. It's going to look just like our player class. And I'm actually just going to go ahead and put the code in here, and then we'll talk about it. Okay, so we have basically the same pieces that we had in our player, but I've added a new function to our enemy state, and actually in the future I will likely add this to my player state as well, because there's some usefulness to this function here and in it. So when this state is initialized, what do we want to do? And I'm going to use this so that we can pass in or grab references to certain parts of the enemy or other classes or variables the first time that the script is loaded and set up. So we're not going to need this on most of our states, or not on all of them. I don't know how many, but at least on some we're going to want that. So I'm going to go ahead and do that. Add this here. But then the rest of the functions will match basically what we had in our player. So we have an enter state. What happens when the enemy enters this state? What happens when the enemy exits the state? What happens during the process update of this state, right? And as you recall, this is going to return an enemy state. Our players were just returned a state, but these ones need to return an enemy state. And what happens during the physics process. And then you'll notice there is one other difference. Our player states had a function for handle inputs. We don't need that for the enemies because they're not going to handle any inputs. Okay, so that's what our basic enemy state class will look like. And let's go ahead and move along to our EnemyStateMachine class. This will, again, look pretty similar to our player state machine. I'm going to go ahead and put some variables in here. So we need an array of states. We're going to want to track our previous and current states. Okay, just like we did in our player class. I'm going to go ahead and remove that comment on my ready function. Now, similar to our player state, we want to set our process mode to disabled when we first load this script, so that we don't accidentally try and run any of our logic before it's ready, before it's initialized. And then we'll just go in here and start adding some stuff. Actually, the first thing we need to do is add our various functions that our state machine needs. So before we update the process function, let's add our change state. This is just like our player, except that we're passing in an enemy state, and then everything else is the same. We check to make sure that it's not null and that the state that we're switching to isn't the same as the current one. And if it is either of those, then we just return. And then if we are currently in a state, we'll exit that state and then go ahead to set our variables and enter the new state. So pretty straightforward. So if you remember, our player state machine had this, just call it initialize. And this is going to require us to pass in an enemy instead of a player. So this is going to look a lot like our player in some ways. Okay. Now within this class, we're going to do a lot of the same things. Let's first make sure we set up our states array, and then we'll get our children, and we're going to iterate over those just like in our player. So if the node that we grab is an enemy state, right, then we'll go ahead and append it to our states array. Pretty straightforward there, I think. So that's just building our array of states, and we're actually going to use that array, or we could use that array more with the enemy than we have with our player, but I don't know, we'll see. So we're going to do something a little bit different here. Actually, we're going to depart slightly from what we did with our player state. In our EnemyState class, I didn't make these static. I didn't test this, but I'm fairly certain that if we did make this static, then as soon as we had multiple enemies, the scripts would all be affecting one enemy instead of the, like 2 or 3 that are on the screen. And so that's something that I want to make sure we avoid. So the scope is not static. These are variables that are going to be per class. In our player state machine, we just set the player within the first state, and then all the other states could grab it. But in this case, we actually need to iterate through all of our states and set up each state. So for S in states, right, for each state in our states array, we'll just set the enemy to the enemy that we've passed into our initialize function. And we'll also set the state machine to ourselves, right? That way each state has a reference to the state machine if needed. And then also we've added that new init function. We're going to call that on each state. Okay, so this is new, but this is I think a good clean way to handle this. Just set up each state, make sure it's got all the settings and things that it needs to run, and then we'll go ahead and check if our state size is greater than 0, right? If we have some states, then this is where we'll change our state to the first one that we have in our array, and we'll set our process mode to enabled, or actually to inherit, right? We want process mode.inherit. Start typing process mode. There we go. So this means it'll inherit its processing from the parent. This will allow us to pause the game. The enemies will pause with it if we need to. Okay, so there we go. I think that's pretty much accounts for everything that we need in our initialize function in this state machine here. One thing we need to do now that we've set up our state machine is we're going to want to go, let's look at our slime. Let's look at our enemy script. We can go ahead and uncomment this state machine. And, well, maybe first we should have added it, but let's go ahead and add a node. Right, and remember with our state machine, we're just adding a node. We'll just call this EnemyStateMachine. And let's put our state machine script on it. Okay, and I already had this code written so that it would be looking for that state machine with that name. So we're good to go there. We do need to initialize the state machine. So that function that we just got done writing, right? We're going to go ahead and call that on the onReady. Oh boy, what am I doing here? Initialize. And just pass in ourself. Because if we remember, the state machine initialize requires an enemy. So we're just going to pass ourselves in here. Now let's handle one other thing. We want a reference to our player. And in order to do this, I'm actually going to go to our globals. I want an easy way to be able to grab and manage things related to our player. So I'm going to create a new script in here in our globals, and I'm going to just call it global player manager. Okay. And this, right now, all we need this global script to do is just to keep a reference to our player so that we can grab it easily whenever we need it. Okay. Then within our enemy state on initialize, after we initialize our state machine, we'll also go in here and just set the player. Oh, actually, this isn't going to work just yet. We need to take our global state and we need to put it in our Autoload script. So let's go to project settings, Autoload, and let's just grab the global player manager. It already gave it a name. I'm just going to remove global from the name, so it's going to be called player manager, and add it. Okay. And now here we can just say player manager dot player. Oop, I removed the player equals, so player equals player manager dot player. So we'll just grab that. This is going to run under an assumption that our player is initialized before any enemies. I don't know, might not be the safest assumption, but let's see. I'm going to go ahead and put that in there anyways. And then let's go to our player script, actually. I'm going to open up our player. And we do want to, right now our global player thing actually doesn't have a reference to the player, but we'll just go ahead and do this. In our player onReady function, we'll say player manager dot player equals self. So we'll set the, we'll just, as soon as the player loads, we'll tell the global, hey, I'm here. In order for this to work, again, our player has to be before any of our enemies in the scene tree. And actually the way that I like to build my projects is I like to make the player something that's always loaded even before we load a level. We're not at that point in the project. So for now, just make sure that any enemies fall further down the scene tree than your player. And then you should avoid any bugs. But if the enemy were before the player, then this script's not going to work, because the first time it looks at the global, it's going to be null. Technically, it might work because we're not referencing the player anywhere else, but you're not going to get an actual reference to the player. And I know I'm rambling. If that doesn't make sense, then maybe just take it on faith unless you get an error and add it to the comments, and we can address it later if needed. Okay, so we've set up an enemy state machine. We've set up a base state class. So we're making pretty good progress here. We're not quite ready to create our enemy state. Let's go ahead and wrap up our state machine. Because what we haven't done yet is our process. We haven't done our process or our physics process. So the process just needs to, just like our player, we're going to call our change state function. And we're going to pass in the current state's process function. And this requires the delta. Okay. And then we're going to do the same thing for our physics process here. Except instead of passing in process, we'll pass in physics and include the delta. And I like to put pass at the end. That pink line just makes me feel like, oh, yay, it's the end of the function. It's nice and clean. But you don't need that. Okay. So while I'm being nitpicky about it, just bear with me. Much better. Okay. So now our state machine's ready. Let me go ahead and save that. Run it one more time. Make sure I didn't introduce a bug. Good, good. We still have one thing left in our debugger. It's just another thing. Process on our enemy. It's not using the delta. If you add an underscore to any of these parameters, then it'll ignore these warnings. And delta is a required argument for process. So until we use it, it might as well just have that underscore there. Okay, that's just an aside. That's not really important. These warnings are more advice or suggestions on how to improve or clean your code. It is how I tend to interpret them, but do what you feel like you want to do with them. Okay, so now let's go ahead and create a state. Let's create a new script in our state folder. And let's call it EnemyState. Let's do our idle state first. Okay. And I'm going to open both of these. So I'm going to go to my enemy state, copy the code, come into the idle state, just delete everything and paste it in here. And then let's just change this to EnemyState idle. And this actually needs to extend enemy state, right? And we don't need this here, but we will keep the rest of the code here. That way we can hook into it if we need it. The first thing I want to do, and I'm going to do this on all of our enemy state classes, I'm actually going to provide a parameter called EnemyName. And this is a string, and it's an export variable so that we can edit it, right? Okay, so, and I'm going to set it to idle in this class. But this way, if you like make another enemy and you call and you give the idle prefix something different than idle, you spell it differently, you can just change this variable here, and then the rest of our code will work and it'll know which animation to grab. So I'm going to go ahead and add a child node to our state machine. Oops, apparently I didn't click in the right spot. And I'll just call it idle. And let's put our enemy idle state on there. Okay. So then now you'll see when I select it, here's the animation name. Okay. We're going to actually add some other things though too, and that's why I wanted to put that on that script and that node in there as soon as possible. We're going to use another export feature, and it's just called export category. And then in here, this accepts a string, and I'm going to call it AI. And then when I save it, you're going to see, oh, it's probably not going to happen until we add our first export property below it. So let's add one of these. This is going to add a category in the inspector, and it's going to be really nice. So for our idle state, I want it to have kind of some randomness to it, you know, so that it's not just repeating identical things every time, like how long are we going to idle for and what's going to happen after we idle. So I'm going to put in here a variable, we'll call it state underscore duration underscore min, and this will be a float. And there we go. We'll just put half a second. And then let's copy this line actually and just paste it, and we'll put a max. And we'll make the default max value 1.5. So these will become the minimum and maximum duration of the state, and we'll pick a random value between them. And you can see after we save that, we now have a section under our enemy state idle. There's an AI header, and we've got our two values. Okay, and let's add one more export variable to our AI category, and I'm going to call it after idle state. And we're going to want this on almost all of our enemy states, so maybe this should be part of the state class, but I don't know. I'm not certain that we will. I'm just going to add it here. So there we go. We've got an after idle state, and it's of type enemy state. So we're going to have to assign one. Right now it's going to be null. And you'll see how that comes into play when we get the wander set up. And then I'm going to add just a variable called timer and make it a float. We could add timers to our scene or do other things, but in this case, we're just going to do something really simple with it, and this variable will suffice. Okay. So let's set up the init. Actually, we don't need an init, I don't think, on this state. Let's do the enter. When we enter this state, we want to just set our enemy velocity to vector 2.0, so he'll stop moving. We're going to, let's take our timer, and we're going to set it to a value, and it's going to be a random float. So random f underscore range. This allows us to get a random float, and you can see we can provide a from and a to. So we're just going to plug in our state duration min and our state duration max as our min and max for that number. So every time we enter the idle state, it's going to pick a random number between 0.5 and 1.5, and it's going to assign that to the timer. And then every state probably needs to update the animation. So let's get our enemy and go call the update animation, and just instead of giving it a string here in this line, we'll use the anim name that we've provided in our inspector. Okay, so it's gonna, in this case, it's gonna play the idle animation. I don't think we need anything when we exit the idle state. In the future we might, but for now we don't. During our process, this is what we're gonna do. We're just gonna count down our timer. So timer minus equals the delta value. So I know we've probably covered this briefly, and that's not time, it's timer. I think we've covered this briefly in the past. The delta is the delta, or the change, the amount of time that has passed since we last had a process called. So we're just going to decrease our timer by that amount of time. And then eventually, right, the timer is going to reach 0 or maybe a little bit less than 0. So if the timer is less than or equal to 0, then we will just return our after idle state. Okay, which right now isn't set, so it's going to be null just like this. But don't worry, once we assign one here, once the idle thing runs out, it's going to go to that state. So this means that this idle state will be kind of dynamic. If you're making an enemy that should start wandering after the idle's over, then you can plug that in. But maybe you have a state that is like searching, and it's different than wandering. And after they idle, you want them to go to the search state, you know? Then you could customize that per enemy. That's why I'm building it this way. And it could probably be more flexible and more robust, but this is, like, to me, a good compromise between like complexity and ultra usability and oversimplification. So I think this is a good way to go. And obviously you could take this concept, add on to it, and do what you want with it. But that's our idle state. It's just going to go ahead and do that. And if we run our project, it should run. Probably shouldn't be any errors, but obviously it's hard to tell the difference between idle state and not idle state because we were already playing the idle animation. So let's create another node, and let's call this one wander. And I want a wander state as opposed to a walk state, because what I want the enemy to do is to just kind of move in a random direction for a random amount of time. So let's go ahead and create a new, I'm going to duplicate our idle state, and then instead of underscore idle, we'll call it wander. Make sure we open the wander state. There we go. And make sure you've got this selected. the wander state, and then let's change the name here to wander. And we'll keep some of these variables. So let's go ahead and change this anim name to walk. That's the animation we'll use. And then I also want to export a variable for this state called wander speed, or walk speed. It could be called whatever you want. Okay, flat, and it's a float. Let's just pick something like 20.0. I'm going to do something a little bit different with this one because I want the wandering, since our slime hops and other enemies might have a walk cycle, that we want it to play a full loop through before it can stop. Like, we wouldn't want to stop the hop animation while he's midair and then suddenly he snaps to the ground, right? So instead of state duration min and max, I'm gonna change this a little bit. I'm just gonna say, let's call this state underscore animation underscore duration. So let's look at our walk, and remember it's 0.7 seconds, okay, in length. We can set this to, I'm actually just going to leave this at 0.5, but let's put this wander script on here. We know that let's see here. Let's go ahead and remove some of these. I'm gonna remove some of this stuff we're not sure if we're gonna use. Okay, just get rid of those errors. We are gonna keep after idle state. Let's get rid of this state duration max for right now. Now let's save this. Okay, so our wander state has this state animation duration. Here I'm going to change it to 0.7 because that's the length of the slime's walk animation. And then let's put two more variables in here. So instead of determining how long to make the animation based on like a random number, we're going to tell it how many cycles of the animation we want. So, or we can call it state cycles, animation cycles. I'm going to call mine state cycles min, and this should be an integer. And I'll just say 1 is the minimum. Like, it should get through at least one go of the walk animation. And then the max we could set to 3. Okay. Now these will show up over here, and you could, again, change these. You might have something that can wander in a direction for a long time. And then after idle state, that's good. I'll keep a timer in here. We're going to need that. We're also going to want a locally stored direction variable, I think. So I'm going to add that. Let's code this out. Let's finish this script. Let's finish this wander script. So in the enter, we're going to set our timer duration just like we did with the idle, but it's going to be set in a different fashion. We're going to say random integer range. And we're going to say states cycles min and states cycles max. So this is different, rand I, because it's an integer and we're getting a random integer. We don't want 1.2 to be a value, right? It's got to be 1, 2, or 3 is what we're saying here. That way, again, the walk cycle, it's going to be a complete number of walk cycles. Then we'll just take this and we'll multiply it by the state animation duration. So then we're going to get a multiple of that, right? So since our walk animation is 0.7, it's going to be 1, 2, or 3 of those long. So we'll get a number of like 0.7 or 1.4 or 2.1, something like that. And then let's get another random number here. And this is going to, since the character or the enemy is wandering, we want to pick a random direction for him. So we'll get a random integer between 0 and 3. And then let's set our direction equal to, look at our enemy. Remember, our enemy has this collection dir underscore 4. It's got our cardinal directions. So we'll just plug our random number in there. So we're going to get a random direction out of that. And we're going to set that to the direction that our player or our enemy is walking. Then we can go enemy.setDirection, and we'll set it to our locally stored direction. And then let's go to enemy and let's update our animation because we got to do that. and just provide anim name in there. Okay, and that's all we need for the enter. Oh no, we need to do one other thing. We should set our velocity. I think we'll do that here in the on enter because we're not going to change it throughout the state. We'll just set it at the beginning. So we'll set our velocity equal to our direction and then multiply that by our wander speed. There we go. Now in this, we're going to do something very similar. Let's just go ahead and in our process, let's plug in our timer just like we did in the idle state. And then when it's done, we should rename this. It's called after idle state. We could just change this actually maybe to be next state. That's a good way to do it. Okay. There we go. Now I think that's good. Okay, so let's look at our states here. We've got this after idle state. Let's drag our wander and drop it onto the after idle state. Okay, so that means when it's done idling, it'll wander. Oh, did I? Yeah, okay. And then let's go to our wander state and put our idle on the next state there. So theoretically, if this all worked, there we go. Our little guy idles for some random amount of time, and then he moves in a random direction for a couple hops. There's 2 hops. He should do 1, 2, or 3 hops. So there's a 3 hopper. 1, 2, 3. There we go. And he's probably, you noticed he ran into the walls and he couldn't continue. He'll do the same thing with that plant here. So he's just wandering around. And this is a really dumb AI right now. And that's okay. You actually might want some dumb AI in your game that just really does stupid things, and they're just kind of the basic easy fodder that kind of gets in the player's way a little bit. Another thing we can do is, you'll notice as we're setting up our state machine export variables, like our wander has a wander speed of 20. Let's go ahead and crank that up to 40 and just run it again and see how that looks. That might be a little bit better. I mean, you can adjust that as you want, you know. 30, 40 might be too fast. Let's try 30. Let's go back. That looks pretty good. Okay, I'll probably keep it there at 30. Kind of like that. So if you are continuing to learn from and enjoy these videos, please give me a like or give me a subscribe or add comments in the comments section and ask questions that you have for upcoming tutorials, or, you know, if you run into problems with this one, let me know. I'd be happy to hear it. And as always, thank you for joining me.